Okay, this is from the 1972 AP Calculus exam, which is safe to assume that they did not have this technology, so we will not be using a graphing calculator, and we're actually not even going to need it. Trust me. So it's going to work out very well. Let's go. They gave us y equals 2e to the cosine x, and they said calculate dy over dx and d squared y over dx squared. So calculate the first derivative, calculate the second derivative. Here's part A in blue. So part A, the first derivative, dy dx, is, okay, the derivative of 2e to the cosine x is 2e to the cosine x times the derivative of that exponent, which would be negative sine x. So we will have negative 2. Let's put the sign in front. Like, it's good to have exponential things last. So negative 2 sine x e to the cosine x. Okay, that is your first derivative, my friends. Let's find the second derivative. So the derivative of that, there's your notation, Leibniz notation, practical stuff. We're going to take the derivative of that again, and actually we're going to do the product rule, and you could do the product rule with this, or you could go back to here, and I'm going to do that, okay? So bear with me here. Why am I doing that? And here's why I'm doing that. Because if I do the product rule with this and with this, calling them f and g, and doing f prime g plus f g prime, then the derivative of f is staring me in the face because this is this, and the derivative of that we already found, okay? So let us move on. Here we go. The derivative of 2e to the cosine x was this, which got simplified to that. So negative 2 sine x e to the cosine x times g. G is negative sine x plus f g prime. The derivative of negative sine is going to give me positive cosine. Okay, this is correct, but we have a little bit of simplifying we can do, make it a little neater. Negative times negative gives me a positive. I have a sine x, e to the cosine x times sine x, so 2, a couple sine x's, e to the cosine x, and then plus 2. Let's put the cosine in front of the exponential. Just conventionally, it looks better. A little more accurate looking. Okay, there's part A, and you're probably thinking, well, these are related rate notes. Where's the related rates? Okay, on free response, they will put related rates in with some other random thing. It just happens, okay? So let's now do part B, and that's where related rates comes in. If both x and y vary with time in such a way that y increases at a steady rate of 5 units per second, at what rate is x changing when x equals pi over 2? What? Let's think about it. X and y change with time. They vary with time. So as time moves on, x changes and y changes. You might be thinking, well, what shape is this? Is this a triangle? Is this a cone? Is this a circle? Is it a... No, it's an equation. And x is changing and y is changing. Okay, so not all of these problems are going to be those nice, neat little geometric things where you're an engineer and you're trying to figure out how fast something is moving. It's not all like that. But this one is just an x and a y. And they said that I can list the rate of change of y with respect to time, and it is 5. It is increasing, so it is positive. And I can also save some space and write dx dt and say, at what rate is x changing? I don't know. When x is pi over 2. Let's keep moving, all right? So what we do is we take the derivative of this, and you might say, we already did. We did, but we didn't, okay? We're going to take the derivative of this with respect to time. So even though it might take us a little, pun intended, time to do that, let's do it again anyway. So y equals 2e to the cosine x. But we're taking the derivative not with respect to x, that happened here, and again here. We're taking the derivative with respect to time. So dy over dt equals the derivative of 2e to the cosine x. We know it, we found it, we got it, it's here, okay? That it's staring us in the face, there it is, it's all this amazingness. So it is negative 2 sine x e to the cosine x, but in the process of doing so, you took the derivative of x with respect to time. So you need this. And that's why we sort of had to do it again. Like we knew the guts of it, but we also needed to do it again so we would have these. Okay, you don't have to write it all out again, but there it is. Okay, let's figure this out. We can keep moving. dy over dt is 5, negative 2 sine of pi over 2. Hope we can remember what that is. E to the cosine of pi over 2 times dx over dt. Okay, let's put some parentheses, just clean things up a little bit. 5 equals negative 2. Sine of pi over 2 is 1. E to the, okay, well, e to the cosine of pi over 2, that's 0. That's also 1. This answer is just beautiful. You might say, I can't do all this in my head. You can. They engineered it to where it's not that bad. So negative 2 times 1 times 1. Check this out. dx over dt is equal to negative 5 halves. I'm going to call it negative 2.5. There are no units other than units per second. So I'm going to write that. Units per second. We don't know what the exact units are.